Let's have a look at momentum. Momentum is a vector and momentum is represented by the letter P, and momentum is the product of the mass of an object and its velocity. Therefore, mv denotes momentum. So e.g. a 2 kg mass moves at 3 meters per second. So the momentum of this body will be the mass multiplied by v. The mass will be 2 kg. Velocity will be 3 meters per second. Because v is a vector, it's important to indicate direction. So 6 kilogram meter per second east. We said momentum is a vector. So that's what you have. Now let's see what happens when I have two bodies, object A and object B. Object A moves at 4 meters per second, and the mass of object A is 1.5 kg. The mass of object B is 4 kg, and the velocity of object V of B is 0. Now, object A moves easterly, approaches stationary object B. Object A collides against B, and object A remains stationary. Object B is set into motion with an unknown velocity. Now, the question is, what is the velocity of object B, which was initially at rest? Now, here we are going to make use of conservation of momentum. And the conservation of momentum says the sum of the initial momentum before collision is equal to the sum of the final momentum in a closed system after collision. So that's what we have. So we must get the sum of the initial momentum, one momentum, two momenta. So you need to get the sum of this. So the sum of the initial momentum before collision is momentum of body A plus momentum of body B, and that will equal to the mass of body A multiplied by the velocity of body A plus the mass of body B multiplied by the velocity of body B. Now, this must also equal to the sum of the final momentum after collision, which is equal to the mass of body A multiplied by the velocity of body A and the momentum of body B. Now let's see here. The mass of body A is 1.5. and the velocity of body A is 4 meters per second. Here, the mass of body B was 0. So plus 0, this will give us 6 kilogram meter per second. And then we go to the momentum of momentum of the system after collision, and then that will be the mass of body A. The mass doesn't change, 1.5 kg. The velocity of that will be 0 after collision, 0. And here we have the mass of that, which is 4 kg multiplied by the unknown velocity. Now, here we had 6 kg meter per second. Now, by conservation of linear momentum, the sum of the initial momentum, which is 6 kg meter per second, by conservation of linear momentum, this is equal to 4 kg VB. We divide right through by 4 second is the velocity of body. Let's have a look at a second instant where we have body A or body X and Y there. And then the mass of X is 2 kg. Velocity of X is 8 meters per second. The mass of body Y is 1 kg. V of body Y is 2 kg, 2 meters per second west, which means this body here moves easterly and this one here moves westerly. We need to get, they say after collision, body A, body X, and body Y couple and moves at the velocity which is unknown east, or just at the velocity that's unknown. Let's say calculate the velocity of the system after collision. Now, we need to get the sum of the initial momentum here before the collision, and you compare with the sum of collision, of sum of momentum after collision. That will be the sum of the initial momentum is equal to the mass of X, V of X, plus the mass of Y, the mass of X is 2 kg and V is 8. The other is they are negative. This one is a negative vector. So that will be 16 kg meter per second minus 2 kg meter per second. This is 14 kg meter per second east. Now let's look at what happens after collision. This couple, they move as one, as a unit. So the momentum of the collision is the mass of x, v of x, plus the mass of y, v of y. But we have just said is a couple, which makes the velocity the same mass. If you are in a car that travels at 60 meters per second, everybody in that car, 4 or 5 passengers, everyone in that car and everything in that car is moving at 60 kilometers per second. So if it moves as a unit, v is the same here. So mathematically, we'll take v out. We'll take v because it's common. And then we put the mass of x plus the mass of y. That is v. The mass of x is 2 kg plus 1 kg. Therefore, by conservation of momentum, the sum of the initial momentum before collision is equal to the sum of the momentum east is equal to v 3 kg. Our bone of contention is to get v. So we divide right through by 3. Three, 12, 2/3 kilogram. Now kg will cancel with kg here. So we'll end with meters per second as the velocity of the system. So the whole system will move at 4,6 meter per second east. Let's look at another scenario. We have here a boy who's on roller skates. There's a boy on the roller skates, and the boy moves at 12 meters per second in that direction. At point A, at point B, his friend throws a ball at him. And there is the ball there. Now the mass of this boy is 40 kg. And the mass of the ball is 1.2 kg. The velocity after the ball has been thrown into skates is unknown of the whole system. Now, let's see what's happening here. We get the momentum before. Momentum before is basically the mass of the ball multiplied by the velocity of the ball, which is 40 multiplied by 12 kg meter per second. This is 480 kg meter per second east. And then we compare with what's happening here. Momentum of that system, which is the boy plus the ball, will equal to the mass of the boy plus the mass of the ball multiplied by V. Now, this will be 40 plus 1.2 multiplied by unknown V. This will give us 41.2 kg multiplied by unknown V, but by our conservation of momentum, 480, which is the initial, kilogram meter per second, should equal to 41.2 kgV. So we divide both sides by 41.2. If we divide by 41.2, remain with the velocity of the system. And then you have 480 divided by 41.2. That gives you 11.6. That gives you 11.65 meter per second. That is the velocity of that system. Let's look at the next one. The next one will be a pendulum. The next one will be a pendulum. There's a block of wood, 2 kg, and there's a bullet that's fired from a rifle. There's a bullet that is fired from the rifle. And this bullet is moving at let's say 245 meters per second. And the mass of the bullet is 0.01 kg. Let's say 0.15 kg, 0.015 kg. Now, this is a string, a light but strong string, and we want to know how far will the block of wood move. Let's say there was no string here. Let's remove a string. Then we want to know how far will this block of wood move. Sorry. We can only know how far will a block of wood move if we know the velocity of the system. We can also get the kinetic energy, which is equal to half mv squared.